And you'll notice that the interface for between standard and pro, as far as the CAD goes, it's exactly the same. There's no additional features in the CAD. What you're going to see is more options in the CAM, and if you notice the machining browser over here on the left under the program tab, you will find under 2-axis you're going to find remachining as an additional option.
Okay.
In addition to the other methods, there would be an add-on in the Pro. Under 3-axis you will see that there's a lot more types of machining operations that are available to you.
Okay.
You would also have the ability to program 4-axis if you plan to add a rotary table to your machine, or if you already have one and you want to program parts on a rotary axis, you can use 4-axis. Now the 5-axis is only part of the premium, so the configuration what I'm running is one level above Pro, which is premium. So the only difference between premium and Pro is in the premium you also get the 5-axis machining methods, which is not in the Pro configuration. You have what is called a multi-sided machining, or also known as 3+2 or positional 5-axis, which is included. So if you go to holes, you can click on it and you have hole machining for 3 and 4-axis as well. And under miscellaneous operations you have 2 more options. One's called the fixture offset, the other one's the XY instance.
Okay.
And we'll cover that as well. Okay? And in terms of simulation, we also have machine tool simulation that's available in the Pro, so you can actually pick a machine tool in here and select that during simulation. Now let's go ahead and take a look at some of the functionalities and features that are included in the Pro. So would you like me to start with the 2.5-axis remachining feature?
Yeah, sure.
Okay. All right. So what I'm going to do here is go into the top view, and let's go ahead and create a couple of geometries in here. So I'm going to throw in a rectangle. You could be importing the files from your CAD system in here, but I'm just going to go ahead and I'll just create it.
I did have a question.
Sure.
I did some mesh modeling where I had solid models intersecting, and I subtracted parts out of one another, and I went to use the feature machining, the features down there underneath in machine browser, and then there's machining objects. I went to the features tab, and it wasn't recognizing that there were any features in the part.
Okay, we'll talk about the feature detection as well. It needs to be a watertight model or closed. If you have open, like if it's not watertight, then the feature detection is not going to be able to determine features, and we'll talk about that in just a moment. So I just created a few rectangles in here, and I'm going to trim them out. So enable what is called the command recall on, so the command stays in a loop until you cancel out of it. So let me go ahead and trim out some of these areas right in here. Let me go ahead and just undo what I had trimmed here, and let's go back and trim some of these sections out in here. So I'm going to do a trim with the command recall on, so I'm going to trim these sections out right in here. So you can see that the command stays active while you're trimming it.
Okay. Now, what does the command recall do? Allows you just
it means it keeps the command in the loop. Basically the command stays active.
Oh, okay, I got you.
So you don't have to go back and click on trim each time. It stays in a loop. And you can hit escape to cancel out of the command, and then you can just click on it again to cancel it. Now I'm going to go ahead and chain all of this together, so I can use chain selection. There's a command to chain it, or you can basically join them together. If you want to do a chain, you just pick one of the curves, and it'll basically chain the entire section. So you can basically select all of these, and also do a merge or join to combine it if you want to combine them, right? So you can select all of it and do a merge, and that'll basically combine it to one geometry. So let's go ahead and program a pocket in here. So we'll do a 2-axis pocket machining, and I'm going to pick this as my geometry for pocketing. We'll grab a large tool in here. I'm going to pick a 3/4 end mill. define all the parameters. You can specify your cutting conditions in here, your tolerance, your step overs. You can choose what cut pattern you want to use. You specify your depth of cut in here. We'll just go 1/4 inch deep, and then we'll put the stock allowance to 0, which means we want to finish right to the edge and generate. So you'll notice that it did program a toolpath, and let's go ahead and define the stock. So one of the nice things you have in the Pro configuration is you could do stock from different techniques in here. You're not just limited to a box stock. I can actually pick this curve and do a stock by extrusion. So the stock what you have is actually pre-cut to a certain size or shape right in here. You can see the stock that's defined. You can align the stock, and there it is.
Okay.
So you can have stock of different shapes. You can also select this in here in the CAD if you want to offset it out. I can do an offset of, let's say, 200 thousandths, and I can pick this to define my stock.
All right.
So your stock is not just rectangular in shape. You could have any arbitrary shape stock. Now we program the pocket operation in here. And you'll notice that because of the cutter what you use, it's leaving the radiuses on these corners in here. So in the standard, you probably would have to go back and run a profile cutter all the way around the part. With the Pro, you have this option called remachining. And you can specify a smaller tool. So let's say I want to go with an 1/8 inch and define the reference operation as a pocket. The previous tool diameter was 3/4. I could even have a slight overlap. I can change the cutter to be maybe 800 thousandths so that you get a nice little overlap on the cut. And you can choose the reference operation. Okay, in cut levels, you put in how deep you want it to cut, and then pick generate. So you'll notice that it only identifies those areas where the corners where the cutter could get in, and programs a toolpath. Now, if you wanted to also assign different colors in here, you can apply based on a tool, and you can go into the operation in here. You can specify a color for each tool that you have defined in here. So I can apply different colors in here and save those tools. Now when I go back and run a simulation, you'll see that it's showing the material removal.
Yep.
Now the ability to specify colors is available in all configurations right from standard. But now you notice that after the pocketing was programmed, you roughed it out, you want to go back and clean it with a remachining operation. So that's one of the tools that you have in the Pro. Now you may also be wondering what this instance operation is going to do for you. So if you're going to be doing multiple runs of the same part, meaning you want to fill a sheet of parts in here, you can do an instance, and you can specify the spacing in here between the parts. So if I go ahead and check, analyze, do a part information, the part length is about 7.4 and width is about 5.5. So 5.15. So I can say I want to space the parts apart by a certain distance in here, 7.5 by 5.25. So I can put in distance between each part and set number of additional copies you'd like to create. So it's going to do array. So if you say 1 in X, 1 extra copy in X, so you end up with 2 along X, and then it takes these 2 and then instances on the Y, so you end up with a total of 4 sets.
Okay.
So you have this XY instance operation programmed. All you have to do is drag and drop these operations into the folder. So now you'll notice that there's a total of 4 copies of the same part. So you don't have to make physical copies of the CAD model. You could just bring in one instance, one copy of the model, and then you can basically create multiple repeats or instances.
The same toolpath.
Now you could also do a polar instance where you can specify the angle to fill, and you can specify the number of additional copies in here. So that'll basically give you 4 sets.
Okay.
So that's...
I do have a question.
Sure.
I was doing a program where I had to drill and ream 2 holes and then use a grooving tool to create a recess for a snap ring. And when I created the grooving tool, I could not get it to drop dead center in the bore. It kept wanting to start from the edge. So basically, I was having an issue with my start point.
You mean, are you talking about the milling module, or are you referring to the turning module?
The mill.
Mill module. Okay, so you said you were defining a tool like a grooving tool.
Yes.
Do you happen to know which of these tool types you chose for it? Okay, so the bore operation is basically like a drilling operation, what you have here. It basically uses the geometry, the center of the geometry, whatever you pick, to establish the center, the centroid of it. And then it's going to create a drill operation. It's just going to drill it at that. Yeah, it's going to be the center. So if you wanted to just have it follow a certain point, you can use an engraving operation. You can create a point, and I could, for example, I can just throw in a point in here, go to curve modeling. I could insert a point, and I can just pick a location of the point right there.
Mm-hmm.
And I could do two-axis engraving, and I pick this point, and I can give it, specify a tool for it, whatever tool that you want to use, and you can specify how deep you want to go. I could say I want to go 1/2 inch in steps of 100 thousandths, and I can apply to do a retract. So basically it'll do like a peck cycle in here. Or you could use a drill operation for it. Did you notice it, Travis?
Yeah. Well, what my issue was is after I had drilled and reamed it.
You want to do a profile cut to clear it out, clear up the hole?
Nope. It literally just needed a 50 thousandths height, 50 thousandths tall groove milled in about 1/4 inch down into the hole.
So it would be like an undercut, basically?
Yeah.
Okay.
It would literally be, so say you just have like a T-slot shaped cutter.
Okay.
And you drop straight into the bore, and then you just...
Okay, I see what you want to accomplish. I can certainly...
yeah.
Okay,
Yeah,
let's go ahead and do that in here. Okay. So first thing I'm going to do is draw a circle in here. I'll just pick a point. I'll put in a circle. I'll use a 2-inch radius. Is that good? Okay. And let's go ahead and first basically program a pocket in here, right? So we want to do a pocket operation, 2-axis and pocketing. So I'm going to basically take the same pocket operation we have in here, and I'll pick this, and I'll give it a depth in here, 1/2 inch deep.
Yep.
So that's going to basically clear all the material out in the pocket. So let's go ahead and create another circle in here. So I'm going to basically pick the same point and use this for defining my stock. And I can give it a height of 1 inch. Okay, so we have this hole drilled right there. We do a pocket, right?
Mm-hmm.
And now I want to go ahead and cut a T-slot in here, right?
Yes.
Right where this pocket floor is. So here's how I'm going to program it. So I'm going to make a copy of this circle. This one right here.
Mm-hmm.
And I'm actually going to make, do you happen to know what would be the width and the height of the slot? So actually I can just pick this circle.
The height of the slot would be, I mean, it's arbitrary right now,
Okay.
but it was 6 thousandths.
All right, so we'll do what is called a 2-axis T-slot machining operation. I can pick this as the geometry, and I can specify the slot start height. So from the top, how far down you want it to start. I'll put in 375. Okay.
Okay.
I want it to this, and then I give it a width in here. Slot height, I'll put in 1/8 of an inch. Okay, and then width of the slot, how deep you want it to go, maybe 100,000 deep. And I'm going to set these as, finish to 0, and then I can choose inside or outside. I'm going to pick inside. All right, and then in the cut control, you can specify the parameters like your step over distance, step down distance. I can specify all of these parameters in here. I'll just go 50 thousandths for each of these. And over here, I'm going to pick a tool, a face mill cutter, and I'm going to reduce the shoulder height. I'll just put in 50,000, the flute length of the cutter itself. It's very small, right? As you can see here, I can make it 100 thousandths, so it's at least visible in here. I'll put in 100 thousandths, save it as to the tool. So with this selected, when I generate the toolpath, it actually figures out the T-slot cutting operation. You can see that it automatically goes in. I'm doing a mixed cut in here. It creates a T-slot for you.
Okay.
So this can be used for like programming slots like these, also like O-ring grooves. So now if you take a look at it, it's basically starting at a height of about 3/8 from the top and then clearing that out for you.
Okay, perfect. Yeah, I was having difficulty making that one happen.
So I can also apply a different color in here for this tool, so it makes it easier for you to visualize it. So you see the slot being cut right there. Now, one of the other ways to do it is if you don't want to use a T-slot machining, but you want to use a T-slot cutter. So the other way to do it is basically make a copy of this curve. I'm going to make a copy of it. And I'm going to select this, and I can put it down in the Z to the depth. So I can use the manipulator in here, and I can say I want to move it down by 1/2 inch. Right? That's where the geometry is, down at the bottom. You see that? And now I can take this and offset it out. I can specify an offset to basically where the slot, the width of the slot ends. It could be like 100 thousandths.
Oh, okay.
And you just want to do a single pass of profile operation. You can do a 2-axis profiling. And I just pick this curve, which I just offset right over here at the bottom. And then we pick the same tool. Now we specify the cutting to be outside or inside. You want to do inside. You specify the entry and exit. So this is where you can control how you want to enter and leave the material. So you could say you want to go at 90 degrees. Specify the length. You can specify those parameters so you can get it out to the center. And then generate it.
Okay. Yeah.
So this is the other way, like a manual way of doing a profile cut in here. But then if you have multiple steps you want to do, in this case the width of the tool, and if the width of the slot is not the same, then the T-slot machining is the most ideal operation in here.
Okay.
Right? I can go back in here and change some of these parameters in the T-slot. I could say I want to start at 300 thousandths. And slot height is going to be, 200 thousandths. And when you generate it, it's going to create those additional passes for you to clear up the material. Right? So when you have variable thickness, or when the thickness of the T-slot that you're trying to accomplish is larger than the cutter itself, all you got to do is pick the edge. You need to have an edge that exactly matches the T-slot right at the top and before where the T-slot begins. And this is also documented in here. As you can see, it's in the help system. It's all documented for you.
Okay.
Would that answer your question?
No. I'm just taking everything in.
Okay. So you have the remachining we talked about. We talked about the XY instancing operation. Now with the Pro, you also have the ability to create multiple setups which means you could have a part that needs to be programmed from the top, maybe one additional side. I can add a new setup in here. I can rotate the coordinate system from which the side you're machining. Let's say you have a part that needs to be milled from the bottom also. I can put in 180, rotate about the X. You will now notice that there's two coordinate systems, the world and then the rotated coordinate system. So I'm going to toggle off the display of the world, and what you're seeing is a rotated coordinate system. From the top, flipped over to the bottom.
Okay.
Now, in this part, if you need to machine it from the opposite side here, let's say we want to cut a pocket in here, right? So I can repeat the same pocket operation right in here, and I can also create a work 0 for that. If I want to put the work 0 to a specific location, I can say set to stock, higher Z, center. I can pick where I need to put the 0, 0 location right there. So you can notice that you can actually create multiple setups in here, and you can also see the simulation from both the sides. So now we have a pocket operation in here, and I can choose the cut levels to start at 0, go only down 100 thousandths deep. So now I'm cutting it from the opposite side as well, and you still have the programming done from the two sides. So if you want to do programming from more than one side, you don't have to make multiple copies of the part and flip them over in the CAD. You can create what is called setups. A setup basically defines an orientation from which you want to mill the part.
Okay. Now that's a feature not available in standard, right?
That is correct. It's not in standard. It's available in Pro. This is also the same way how we program positional or indexed 5-axis milling. It's called 3+2 machining. That's how we do it.
Okay.
You can basically rotate the coordinate system to any plane, any orientation in programming.
That's a pretty neat feature.
Yeah, you have multiple setups. And you can have zeros defined. So this could be your G55 in here. So you could have a G54, G55 defining different work offsets.
Mm-hmm.
Okay?
Okay.
All right. So being able to define multiple setups, multiple orientations allows you to program from different sides. So makes it easier, your programming workflow. Okay?
Okay.
All right. So now I'm going to go ahead and extract just a curve from this face in here. And let's take a look at some of the 3-axis methods in here. So we'll start with the roughing process. I'm sure you're familiar with this process in here, right? So you can specify a tool, you can establish your parameters, and then pick generate. So it's going to create your 3-axis roughing operation. And now we have the toolpath generated. I'm going to hit simulate to end. So you'll notice that once the roughing is completed, since the tool what you used is large for some of these areas in here, right? You can see there's more material being left in some of these areas. So if you want to go back and rough it out again with a smaller tool, that's a nice feature in the Pro, which is called re-roughing. I can go back and rough it with a smaller tool, and I'm going to use a 1/4 inch from a 1/2 inch end mill, specify the parameters. I can even reduce the stock to be left, so I want to go as close as possible to the actual finish shape of the part, and I can control all of these additional parameters and generate it. So this re-roughing operation, it looks at the stock that's being left from the previous step, which means it takes into account the in-process stocks. As you notice here, it's only roughing what needs to be removed from the previous step. So that's a re-roughing operation, and now I'm going to apply a different color in here for this operation. Go to properties, I'll pick a different color. So that was the first operation. The next one, you will notice that it's actually going in and removing that additional 15 thousandths. So you can see it's not hogging all the material out in the center here. So when you're working with parts that require multiple roughing operations, going from a larger tool down to a next level smaller tool, re-roughing is a very good option.
Okay.
Now we also have what's called a machine tool simulation that's available in here. So you can go into load from file. You can pick a machine tool in here. So we have a standard library of machine tools that are built in here. You can select it from the library in here. So for example, if you're using a Haas, you can pick the VF3, or if it's a generic CNC mill, I can pick this here. And you'll see that it displays, gives you a representation of the mill. And now I can go ahead and run this verification. And if I click on show machine tool, it actually shows it with the machine tool.
Oh, okay.
This is just for visualization and verification purposes.
Mm-hmm.
And you could always do a pause to pause the simulation. If you pick go to end, it'll run through the simulation. So from roughing, we did a re-roughing process. Now let's go back and take a look at some of the other methods in here. So I'm sure you're familiar with like parallel finishing operation, horizontal finishing, that are available in the standard. In the Pro, you have methods like 3D offset pocketing, which is constant 3D step over pocketing, or also known as constant scallop machining. So you can pick a boundary curve, which is going to be a part region. You pick a tool for it. You set your feeds and speeds, your cutting parameters. You can set your step over control, and you can choose whether you want to start from the outside or inside. I'll just pick outside and generate it. So this method gives you a uniform 3D step over. So this will result in a better finish as well, and gives you more control on the toolpaths. Now you're noticing that I have this multi-threading manager open while it's being generated. I can also create additional operations. For example, I can do a method called between two curve machining. I can have the toolpath just morph between these two curves. I can pick a tool and then generate it. So this method is called between two curves. So you're basically flowing between the two curves. So I can go back and make a change in here. I can drop this boundary, remove active. I can go back and select this curve edge in here and generate it. So it's going to basically create a toolpath to morph between the two curves.
Nice.
So that's between two curve finishing, and this is the 3D offset pocketing we created, which is a constant 3D step over.
Can I see that simulated real quick?
Absolutely. Let's go to the Simulate tab. I'm just going to simulate it without the machine tool simulation toggled on. Now here the step over, I left it as 25%, so I could tighten up the step over.
Mm-hmm.
But here you can see that it gives you a nice uniform step over.
Okay.
So rather than having to do a horizontal finishing and a parallel finishing, a combination of the two.
Yeah, you can do your outside edge without doing entire. Seems like it's probably more efficient.
Right. So you have more options, more ways to finish, more options, more techniques for finishing. Now this could be like a pre-finishing, or it could be a finishing operation.
Mm-hmm.
So that's the constant step over machining, or also known as 3D offset pocketing. So the between two curve machining we just talked about is basically the toolpath is generated between the two curves that you pick, and it morphs between the two curves. So here I chose to do a zigzag cuts. So when I run a simulation, you will notice that the cutter traverses back and forth between the two areas. So there's a between two curve finishing toolpath. Now let's talk about the toolpath editing, right? The graphical editing you wanted to go over.
Yeah.
So if you go into any one of these operations and you actually expand the operation in here, you'll find this object called toolpath. When you double click on it, it displays a toolpath editor which could appear either below or on the side. And with this toolpath editor, there's several different options that are available to you here. So for example, I could go under Selection Edits tab, and I can pick a specific section of the toolpath using a rectangular selection. And if I want to just go ahead and drag a rectangular pick in here, I could select an area on the toolpath. So you can see that I made a selection, and all of those toolpaths are highlighted, what you selected.
Alright.
So with those areas being selected, I could delete those toolpaths out. I can do a cut selection. It automatically trims them out and puts the retracts in there. So that is called graphical toolpath editing. You're graphically altering or modifying the toolpaths. And these are non-associative edits, which means when you regenerate the toolpaths, it's going to put it back to its original state.
That's pretty neat.
Yep. So you can edit these toolpaths in here. You can also select certain toolpaths in here, and you can convert them into curves. For example, if you want to use like an engraving pattern you want to put on these, right? You can select certain toolpath motions in here and convert them into curved geometries. So you can go ahead and highlight a bunch of toolpaths. I can just select them here, and I can convert them to a curve. It'll let you convert it to just a CAD geometry, and you can use that for processing a different operation. You can also apply toolpath mirroring. This is one of the cool features I like about this toolpath editor is you can graphically mirror the toolpath. So when you have parts that require two halves, like a left half and a right half, so you can actually go ahead and do what is called transforming of the toolpath, and you can specify whether you want to move, rotate, mirror, or scale. And you can specify a point that you want to mirror about, and I can choose the plane I want to mirror about. So let's say I wanted to do the two halves, and I can basically choose the plane I want to mirror about. In this particular step, I'm going to pick the Y and Z plane, and I will pick a point and create a copy. So I'm going to pick the midpoint of this and then create a copy. So you'll notice that the toolpath is being mirrored right over there.
Okay.
So it's mirrored about the point right there. So if I go back and undo the edits, it'll undo the toolpath's edits. So I can basically choose another point in here, do a transform toolpath, mirror, and you can pick mirror about the center or origin. You can specify the location you want to mirror it about, or you can say max point, and you can pick the plane, create a copy. That'll create the other copy for you. So you have two halves right there. So you don't have to create two halves of the cavity, like the left and the right, or if you were working with, like, for example, you're working with a mold for a shoe, you want to do the left and the right, so you just have to do one and then mirror it. So this is mirroring of toolpaths. You can also do a scale. You can move toolpaths. You can reverse the toolpaths. You can instance toolpaths. You can do a Z instance. You can fit arcs to toolpaths and linearize toolpaths. Now these are all global edits, which means any edits that you perform will apply to the entire toolpath that you have in here. Now we have what is called selection edits. We just briefly looked at it a short while ago, where you can select cuts. You can also pick a closed area in here and pick a region. So for example, I could throw in just a simple curve in here. So I have a curve drawn. I can say select cuts inside a curve. So I'm going to pick this curve, and you'll notice that it automatically picks all of the toolpaths in that area. And now we can apply an operation to it, whether you wanted to, what type of operation you would like to perform on it. So for example, I can go in and say select the cuts, pick the curve, and then right click. So you can see this, the toolpaths inside that curve what you created is selected now. I can also isolate it, or I can move it up in the Z. I can say move it up in the Z by 1/4 of an inch, and those toolpaths have been actually transformed up in the Z by 1/4 of an inch. So you have selection edits. You can select certain toolpaths. You can either cut, delete them, isolate them, or move selections up in the Z, or you can even convert those to curves.
Can you go right into the G code and manually edit any positions or anything like that as far as just typing them in?
Okay, so when you post-process toolpath, right, let's do a post. And we typically post it out to a notepad, or you be using any like a third-party editor. I'm going to do a post, and I actually have a third-party editor in here, and this is where the posted code pulls up right there. So you can manually modify these code in here.
Yeah.
You can edit this out. But if you wanted to the same edits to go in on each and every program, we can help you modify that in the post processor.
Okay. All right.
So this editing
one more question
after you post it out.
all right. One more question in the toolpath editor. If you click on a line, will it show you what position or where it's at in the simulation?
Absolutely. When you click on it, it actually shows your XYZ values. That's your what's called a cutter location.
Okay.
And you can also, if you want to go to a specific area and find out what the coordinate value in here is, I can go into selection edits, and I can actually pick a rectangular, make a rectangular selection, drag a window here, and it highlights that particular line. That's your XYZ value. And you can also change the way you display the tool. You can go under simulation. You can change it from a solid to a wireframe. So you can actually take a look at the tool in a wireframe view, and you can see where the tip of the tool is. And you can step through this here. It shows you the coordinate positions.
Okay. There's a lot of extra features.
There is a lot of features, absolutely. And you have more options under 3-axis machining. You can also do a stock by selection where, if you have an irregular shaped stock that you wanted to start out with, you can highlight it and do a stock by selection. So your stock is actually what you imported.
Okay.
And we have advanced 3D finishing methods like pencil tracing and remachining in here. You can go ahead and click on pencil tracing, and this automatically identifies like bitangencies on the part, and it creates a toolpath to go ahead and clean up those sections. So you don't have to worry about doing a manual finishing operation. So you can use these advanced 3D methods to do a cleanup around it. So now if I run a verification in here, you'll see that it's cleaning up those areas. So wherever you have bitangencies on the part. So that's a very nice feature which is offered to you in the Pro. So just to summarize, we talked about machine tool definition, like machine tool simulation in here. If you just want to do manual definition, you can switch it back to manual, and it's not going to show the simulation with the machine tool. You also have 4 and 5 axis capabilities, index 5 axis with the Pro, which is 3+2 machining, where you can program from multiple sides if you want to cut pockets or holes or other types of features from different orientations. You can do that.
I have a quick question for you about the 3D machining. Is there any cutter compensation for doing a part like this?
A cutter compensation?
Yeah, as in like,
Are you trying to do an additional compensation for a tool wear, or are you looking to do like a G41 or a 42, which is typically done in like a two-axis operation?
yeah, we'll just say some of this part that you have on the screen right here, like this large curve in the back.
Over here?
Yeah, yeah.
Okay.
Just say certain parts they had radius gauges or whatever the case may be, and it was being checked and it was off by say a couple thousandths or whatever the case may be. Is there any sort of offsetting or any sort of dynamic offset that would help you create a more accurate rendition of that part? That's all I was asking.
Okay, so are you trying to make the cuts to go past the the part itself, like you're trying to either shrink or you want to make the part slightly larger than what it is designed? Is that what you're trying to accomplish?
Yeah, basically.
Okay.
If you needed to create a tighter tolerance on one part, shrink it or make it
Okay, so what we could do is, for example, if you look at a finishing operation like parallel finishing, and let's say we are programming with a quarter-inch ball mill here. Now in the cut parameters tab, you have tolerances and then the stock allowance. So by default, on a finishing operation, the stock is defined as 0. So which means that the tool paths are programmed to the actual part surface. It's not either going to be overcutting it or making it larger or smaller. So if you wanted to make it go past the part surface itself, you can use a negative stock offset in here. Now the negative value could be like 10 thousandths, 15 thousandths. You can go past the cutter radius. So for example, if this is a quarter-inch tool, I can't go past an 1/8 inch, but I can say I want to go overcut it by 50 thousandths. So it'll uniformly offset it in 3D and overcut it by 50 thousandths.
Okay.
So you can see part of the tool paths are beneath the surface. If I go ahead and look at the wireframe view, you'll see that it's basically the cavity is now larger by 50 thousandths.
Yeah.
Would that help?
Yeah, no, that definitely helps.
So if you leave a positive offset in here, it's going to stay off the part surface